So in this session, we are going to talk about introduction to decision tree. What is decision tree? Definition and overview. What are the key components of it? Application of decision tree, use cases in finance, healthcare, and e-commerce, and advantages and limitations of it. And then we'll talk about decision tree fundamentals. What are the splitting criteria? What is Gini impurity? What is entropy and information gain? And then we are going to look into some popular decision tree algorithm, ID3 algorithm, C4.5, CART, and then we'll look at decision tree in practice, feature selection and importance, like how you will select the features in a decision tree, understanding which feature contribute to the most. And then we'll also look at the random forest, how random forest work, feature randomness and bagging. And then we'll look at some decision tree applications like the classification task, fraud detection, customer segmentation, disease diagnosis, and then regression task, stock price prediction, house price forecasting. And then in the end, we will do some practical implementation. We'll build decision tree in Python. We'll be using some Python libraries like Scikit-learn, XGBoost, and we'll do some hands-on project for a classification and regression. So let's first look at what is a decision tree. So as the name implies, it's a tree of decisions, and that's how humans make all the decisions. We always have this big decision tree and we go through all the nodes. So for example, I want to go and play tennis. So first thing I want to check, is it raining, right? And if the answer is no, then I will say, is it humid? And if the answer is no, then I will play tennis. If the answer is yes, I may not play the tennis. If it's raining, I will not play the tennis. So as you can see, this is a tree and decisions are made at all different nodes. So as you can see, this is the root node. These are the leaf because this is where my tree is ending. And this is the depth of the tree, like how many nodes are there from the root till the leaf. That's the depth of the tree. And these are the decision nodes. Here I'm making a decision of should I go left or right. It's yes or no. And then I'll make another decision. So this is a very, very simple example of a decision tree. Now let's look at a real example. So a decision tree is a supervised machine learning algorithm used for classification and regression tasks. So what we mean by supervised learning, by that we mean here are the input parameters. This age, income, student, and credit rating. This is the input parameter. And this is the target, that somebody will buy the product or not. So this is what we mean by supervised learning. We train the model and then we will give them a new data, just age, income, student, and model will predict whether somebody will buy the product or not. So that is the high-level definition of a decision tree. It's a supervised machine learning algorithm. So the question comes, which column should I choose to split the data? Actually, we have to choose the column on which, when we will split the subset of the data, we should gain the highest information gain should happen. We'll go more detail talking about what is information gain, and the lowest impurity. It's called Gini impurity also. So we'll go in detail, but for this example, to move ahead, I will say I will take this age as my root node and say if his age is less than 30 or not, right? And if age is less than or equal to 30, then I have credit rating. There are two options are here. So maybe if I say yes here, right, then I should be asking what is my credit rating? And is it fair? Then it means I'm not buying the product. And if it is excellent, then also I may not be buying the product. But if age is greater than 30, let's look at these last two rows, right? No, it's more than 40. Then we will see these two columns have the same value. Then we will check again the credit rating. And then we'll say, if it is fair, I will be buying the product. And if it is excellent, I will not be buying the product. So this is another example of the decision tree with the data. Now we should talk about the Gini impurity and what is the information gain and what is entropy, to understand which column we should choose to split the data. Now here we took this root node age, but once we will understand what is the Gini impurity, we will be using those things to split the data. Here, just randomly to explain the concept, I chose age. So now let's look at what is Gini impurity. So to understand Gini impurity, let's look at this data where I have three columns: color, size, and class. Okay. Now the question is which column I should use to split the data. Is it color or is it size or class? So for that, I'm going to calculate the Gini impurity. So Gini impurity is a metric used in decision tree to measure the degree of impurity or randomness in a data set. And when we will look at this example, it will become very clear, because we are talking about, we want to measure the degree of impurity or randomness in a data set. So now let's look at the column which is class here. And what is the formula for Gini impurity calculation? It's 1 minus summation of, this is the proportion of square of each element. Let's break this equation in more simpler term. So here I have two classes, right? A and B. So PA will be total 10, right? And how many A's are there? 1, 2, 3, 4, 5. So this is 5. Okay, same way PB, this is the proportion of B elements. That will be again 5 by 10. So the Gini formula says it's 1 minus PA square plus PB square. That's the formula, right? Sum all the proportions here. And so what we see in 1 minus PA square is 5 by 10 square, and then plus 5 by 10 this square, and this is 1 minus this value. So this will become 1 minus 0.25 plus 0.25, which means 1 minus 0.5 is 0.5. So here the Gini impurity is 0.5. You don't have to worry about all this math which I did, just to explain. When we will be running a Python code, this all will be done automatically for you. So you can see here the Gini value for this is 0.5. Same way, if I go and calculate the Gini value of color here, right? Red is 3, green is 4, blue is 3, red is 3, and we'll put these values in here, and then what will come, the color will be 0.467. This is the Gini impurity value, and for the size it will be 0.320, and this is 0.5, right? So the column which we want to choose will be this column, size, because the Gini impurity is the lowest. As you can see, it's 0.32. So that's what we mean by Gini impurity. So what we learn here is splitting on size reduces the impurity more effectively than splitting on color. Color is Gini impurity is higher, 0.46. Okay, this means that the size is more informative in separating the classes A and B in this data set, right? So this is how, even if we have 15 columns or 20 columns, we will be using this Gini impurity to figure it out on which column we should be splitting the data. So now let's look at what is entropy. So entropy is a metric used in information theory and machine learning to measure the amount of uncertainty or impurity in a data set. So in the context of decision tree, entropy quantifies the disorder or randomness in a node. A node with homogeneous data, what does that mean is all samples belong to the same class, has low entropy, while a node with evenly distributed classes has high entropy. So see this color, it has red, blue, green. So there are multiple classes of the color are there. So it has a high entropy. This seems low entropy compared to the color because there are just two classes. If everything would have been AAA, then it would have been very, very low entropy because all samples belong to the same class. There's no uncertainty, there's no impurity. Okay. Now let's look at what is the formula to calculate an entropy. So the formula is, the entropy is minus summation of I from 1 to k. K is number of classes. Like here, I have 2 classes, right? So that will be 2. And then pi multiplied by log of pi. Log 2 of pi. What is pi? Pi is proportion of samples in class I. Proportion of samples. So if I say PA, it will be 5 by 10. So if you put all this, you will get the entropy value. Okay. I'm not going much detail in the math. As you can see, it is very, very simple math. But when you will use it in your algorithm, it become much more simpler. But just get a concept like what is entropy. And remember this, when entropy is 0, it means it is pure, there's no impurity. All sample belong to a single class. And when the entropy is more than 0, the impure nodes with mixed classes are there. So now see how entropy is used in decision tree. So another thing we have to calculate is what is the information gain. So the information gain is a measure used in decision tree to determine the feature that the best separate the data into classes. Like which feature we should use. It quantifies the reduction in entropy achieved after splitting the data set. So entropy we have calculated for all the data set here, HS. And then we want to see what happened. We will calculate again entropy after splitting the data set. And that's how we'll find out the information gain. So quickly, I will just show you this formula for information gain, but don't worry about it too much. So information gain of this class A, if we are on a feature A, right, on a feature A, the data set S is there. So the information gain on data set S for the feature A, which can be the class, the formula is you get the entropy of the original data set and minus it and then sum it with 1 to m. And m here is number of such subset created by splitting on features A. So number of subsets may be 2 here. So m will be 2. And then number of samples in subset I will be here. Sorry, number of samples in subset I, which will be 5 here, right? And then number of samples in the whole set, which is 10. And then again, you will calculate the entropy of each set. So that's what will happen. We'll split it, then calculate the entropy for that, and that will give you the information gain. So this is how you calculate the information gain. Again, don't worry too much about the math. Math is just there to get some concept and understanding that what is and how is information gain is calculated. But when we will use it in our real life, we will see in Python how easy it is to quickly figure it out. So what happened? The higher the information gain is, right? The higher the information gain is, indicates this indicates that the feature provides a better separation of the classes. So that's what we should be using. So entropy, we used two kind of algorithm. There's one algorithm called ID3 and one is C4.5. Here we use entropy to split the data. And when we were using Gini impurity, we used a algorithm called CART, C-A-R-T. We'll look into it in more detail, but just so you know, CART uses the Gini impurity. Okay. Now let's look at the code in Python, and we are going to use this CART algorithm, and our criteria is going to be Gini. So looking at this code, as you can see, we imported a couple of libraries and then we loaded the database of flowers. How this data look? It's look like this. It has the sepal length, width, petal length and width, etc. And then the target. This target is 0, 1, 0, 1, 2, etc. What this target is telling us, it is telling us the family of flowers, what species the flower belong to. So let's try to see if we can look at the target values. So for that, let's break it here somewhere and we'll run the code and then we'll see. And let me explain the code before we'll run. So let's look at this. So we take the data and we create a split between training data and test data. And that's what we are saying. The 30% of data will be test and the rest will be a trained data. And we create this random state. So the randomly the rows will be chosen between test and the trained data. And we give this 42. This is our, you can give any number, but generally in data science, we use 42 as a reference to the Hitchhiker Guides to the Galaxy. So once you split this trained data and test data, then we create the decision tree classifier. And here, as you can see, we gave Gini impurity and we could have given entropy also. So once we get this classifier, again, random state here, again, we give this. So this randomness is needed sometime. As we know, the decision tree are very deterministic in how they split the data at each node using Gini impurity or entropy. But sometime it can happen, the split criteria yield multiple equally optimal splits. So the algorithm may randomly choose one of them. So that's why you put this random state and always give a seed. So the results can be tested between one run to another run. After that, once we have the classifier, we train the model. This is what we mean by training the model. We gave the trained data and just say classifier.fit. We are so fortunate that we came late and we are standing on the shoulder of giants. Somebody went ahead and wrote all this complex code for us to train the model. Remember how we saw all the math is happening when we are using the Gini impurity or entropy. All those things is happening behind the scene and we just write one line. So this is something to note. A lot of people get scared of computer science because there's a lot of math is used. But when you are working on an application level, you are just writing something like this: criteria is Gini, train the model, and you're done. So it is very simple. So of course it is simple, but don't fool by the simplicity. Why? Because I'll show you something. As a data scientist, you may have to go and look at this decision tree classifier. All this parameter, what should be the maximum depth of the tree, splits, leaves, weight on the tree, maximum number of features, all those things. So each parameter of this decision tree, you have to play with different numbers to see how it is working. And so that's where the work of a data scientist comes in play. And then after training, you just call predict and pass the test data. We'll break here and we'll see how the test data looks and all that. And then it predicted. Then we take this prediction and compare it with our test data. And then it will get us an accuracy score. Very, very simple code, just few line of thing. But the concept is very powerful. You are doing here using a decision tree, and the same decision tree is used in drug discovery or finding out what stock you want to buy. All those things. We'll talk more about some examples later, but let's run this code and see how it works. Now I'm running it. So let's look at the data which we have. As you can see, it's a double dimensional array of these numbers, like 150 numbers are there. All this are parameter, which we talked about here, right? Sepal length, petal length, and width, etc. And same way, the target will be all 0, 0, 1, 2 will be there. We are not seeing, but if you'll see, they will be 1 and 2, etc. Whatever it's showing is all 0, but that's not true. It has 0, 1, and 2. And then here we are splitting the data between training and testing. So let it go. Now I'm creating a decision tree classifier. Okay. Now we are saying fit the model. Now it worked. Now we are saying predict the model, and we are passing the test data. Test data, again, as you can see, it's a double dimensional array, and these are the values here. So the prediction is made, and now let's test it. So the prediction is made, and now see the prediction here. It's 1, 0, 2, 1, 1, and all that. And now let's see, compare it with the test data which we have, which is part of our training. And accuracy is 1. So our model is pretty good. So it predicted everything perfectly. So we have seen one algorithm called CART. So there are other algorithms for decision tree called ID3 and IDC.5. Don't worry about this detail. I'm sharing this all with you in a README file. So let's look at this README file, how it looks. Here you can see these different algorithms, and we will compare them. So splitting criteria, as we've seen in CART, we are using Gini impurity for classification. And here in 4.5 we use gain ratio, and in ID3 we use information gain. And data type supported, as you can see, ID3 supports only categorical, and 4.5 categorical and continuous, and CART also. So when we say continuous data, by that we mean you can have a data for salaries or age, things like that, where you can use some numbers. Pruning, we did not talk much about it, but what pruning means is when the tree becomes too complex or too big, we can prune some of the branches, which is not adding much value in figuring out the results. They may be just kind of a noise. We can look into it much deeper later on. But as you can see, the pruning is not supported in ID3. So that itself, it tells you that it is for very simple a tree, you can use this algorithm, but if it's a little complex, you would like to go to cart or 4.5. As you can see, a regression support is only in cart. So when we say regression support in the context of decision tree, it means the algorithm can handle regression tasks where the target variable is continuous rather than categorical. So in classification tasks where the goal is to predict a discrete class label, whether the data belong to color red, blue, green, in regression task, we aim to predict the numerical value, like what will be the price of the houses or a price of a stock. So that's where the regression comes in picture. You can see the missing data again is handled by cart and ID4. Now this table is important for you to figure it out, which algorithm to use here. And you can see their strength and weakness here. So as you can see, these different algorithms can be used for different kind of applications like weather prediction, disease diagnosis, and fraud detection, spam detection, all those things. We use decision tree to figure it out. Now, we talked about this algorithm called C4.5. Let me show you how different it is than what we did before. So before we used the cart algorithm and we set criteria as Gini. And C4.5, this is the only change. The criteria is now entropy, and that's it. And the same algorithm you can use here. So let's talk about a couple other examples where we can use this decision tree. One is we use it in product recommendation, where we take a decision tree and analyze user behavior and classify customer into different customer segments, and then use other techniques like collaborative filtering and neural network to personalize the recommendation. Same thing, we can use it in ad targeting. Again, decision tree is used to segment user based on their search queries, browsing behavior, demographics, salary, education, things like that. As you can see, wherever I have multiple features, and it's very straightforward classification that if somebody is having this education and this salary and this kind of background, living in this zip code, and what kind of a customer segment this person belongs to. We use it in fraud detection also. So decision tree classifies transactions as fraud or they are legitimate based on features like transactional amount, IP address, user behavior. And then again, we use different other methods. One of the ensemble method we will be talking in a few minutes, which is called random forest, to reduce the false positive. So decision tree has another problem where it overfits to the data because it's a simple algorithm. Content recommendation, again, using first decision tree to segment the user depending on his history, rating, preference, and the viewing habits, etc. And then we use on top of it, again, some advanced model, collaborative filtering and deep learning to enhance the personalization, malware detection. Even driver and rider matching is, again, using this kind of algorithm when Uber is trying to match a driver with a rider using this decision tree, depending on where the driver is available, distance, traffic condition, ride, pricing, and things like that. Credit score, that's again another use. So decision tree again classify loan applicants into approve or reject categories based on features like credit history, income, debt to income ratio, etc. Even in autonomous car driving, we use decision tree because we figure it out the structured data from sensor and camera to decide actions like brake or lane change and accelerate. And then of course we complement this algorithm with neural network and real-time images and video processing. So multiple algorithm works together. And when we will see the random forest, where we will see that multiple trees will vote on certain things, and we will take the consensus of all the different trees and say whether I can have my rocket launch or not. Airbnb may be using it for pricing optimization. again, looking at the features of location, property type, availability and demand, etc., you can figure it out what can be the price for a particular property for a customer. Music recommendation in Spotify, risk management in banks, healthcare companies using disease diagnosis. All these use cases will be using decision tree. Of course, this will not only be decision tree, there will be other algorithm with decision tree, but decision tree is one of the very major algorithm of computer science. Now let's talk about random forest. So random forest is an ensemble learning method that combines multiple decision tree to create a more robust and accurate predictive model. So what happens is we have the data and we create multiple decision tree out of it. And then we take their result. This is kind of a voting. Every tree is voting and then you aggregate and figure it out, the final result. It is used for both classification and regression tasks. And it is known for reducing overfitting and improving performance by leveraging the wisdom of the crowd. As you can see, each tree is giving its own result. And how these trees are created. So random forest creates multiple decision tree by training on different subset of data. So for example, if I have a data where I have these company names and their P ratio, EPS and all that. So I will create multiple tree out of this data and that can look like this. Like one tree is like choosing these 2 features. One tree may choose this 3 features and one tree may choose this 4 features. So using these different tree, we will try to figure it out. What is the right answer? What is the final prediction? So for classification, each tree vote for a class and the majority vote is selected as the final prediction. And for in regression, the prediction for all tree are average of the product of the final output. Now, what is the advantage of this regression tree is it reduces the overfitting. By averaging the prediction of multiple tree, random forest reduces the risk of overfitting, which is a big problem of decision tree because it overfits. So this random forest fixes that problem. It can handle data set with missing values and maintain accuracy. And it works for both classification and regression. And it provides a measure of feature importance, helping identify the most influential variable. I'll show you a diagram where we'll see that which feature has the best outcome, has the most influence on the result. And of course, training multiple trees can be a resource incentive. And compared to a single decision tree, random forest models are harder to interpret. So it is a little difficult to figure it out why that all these trees are choosing this final result, because there are multiple trees and these trees have different feature sets. So it's a little complex, but many times we see this random forest improve the result remarkably. So now let's take a look at the code. So here we are looking at the random forest code, and as you can see, we chose the same data set where we have this iris data set. The only thing we are changing here is saying random forest classifier and 100. That 100 means create 100 trees. Okay, and random state again for randomization, and we give a fixed seed number. So all our run will have same kind of randomization, or I can use 10. 10 trees will be there in random forest. And then same way, you do the fit, you train the model, and then you predict it. And then you check the accuracy and report. So let's run this. Let's run it with 100 first. And as you can see, it is showing the accuracy is 1. Right? And then we are printing the report also. And you can get this report using the classification report. Here you can see the precision and recall. I have another video where I go in depth defining what is precision and what is recall. And F1 score is a metric used to evaluate the performance of a classification model, especially when the data set is imbalanced. And it is the harmonic mean of precision and recall, balancing the trade-off between these two metrics of precision and recall. So this is F1 score. So as you can see, our precision is 1 and accuracy is 1. So this is a perfect model. So remember, in the flowers database, the target was different kind of species, families of species. So it just shows species 0, there are 19 data is there, 19 row of data is there for 1, 13, and for 2, there is 13. So this is a quick example of random forest. And now let me show you the last thing, visualization. Here I am going to show you which features are important. And let me run this. So this is we took the classifier, we trained it, and then we are taking the feature importance, and then we are plotting the graph. And here is the graph. As we can see, petal width is the most important feature, and then the length. And sepal width is not that important. So this is one way. Another way to figure it out of all the features, which one is the most important. So thank you for your time. If you stuck around till here, I hope it's worth your time and you learn something about the decision tree. Of course, there's a lot to learn here, and we try to cover a lot of ground in 1 hour, but I hope we gave you enough introduction, understanding of this decision tree that you can now drill down by yourself. And please let your feedback keep coming. Let us know what else you'd like to see on this channel. Thank you.